Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello everyone, wherever you are. I want to appreciate your joining me once again on this channel. We are going to start a new series on differential calculus. And in today's topic, we are going to look at the rules as much as we can on solving questions or problems referring to differential calculus. Differential calculus is a branch of mathematics that has to do with calculating change in two variables that are not straight, where you have variables that have power, where you have variables that are raised to power. So the change that happens between these two variables is what we use differential calculus to determine. And when we're calculating differential calculus, we are referring to deriving what we call the derivatives of the changes between these variables. And actually, this is where we have cases of having to find the marginal change or marginal increase or marginal values of the total values of certain variables, like finding the marginal cost of the total cost, or finding the marginal revenue of the total revenue, or finding the marginal profit in a particular investment from the total profit. That's the additional profit or whatever. So this is what we refer to as differential calculus. For students, wherever you are, you might be hearing something like where they say dy dx. When you hear dy dx, they're talking about change in y based on change in x. That's what differential calculus is trying to do. So today, as we work along with me, we're going to look at how we derive the derivatives of each function in differential calculus. We may not be able to finish all the rules in this video, but in subsequent videos we are going to continue from where we stop in looking at some of the rules of differential calculus. Thank you very much for joining me once again. If you've not subscribed to my channel, please do. I really appreciate that you subscribe and share this video with your friends, with your colleagues, wherever you are, to join us in this project that we are doing. You're very much welcome. Now on our board, we have a blank board here, which we're going to be filling up with what we're going to be writing. So that the first rule, I'll write here, rules for determining derivatives. So these are when we differentiate a function, we call that derivative. The results are derivatives. When we differentiate a function, the outcomes are derivatives. So the first rule we're going to be looking at is what we call the constant rule. The constant rule. And in the constant rule, it says that where you have a function that is a constant represented by k, we have a function which is equal to a constant k, the derivative of the function will be 0. This is the first rule. when you have a function that is equal to a constant k, the derivative will be 0. This is because there is no independent variable in the function. Now, in a typical function, you have y is equal to a plus bx. But in this case, you do not have any x. This part of your function is not there. So since there is no change here, motivated by the coefficient x, it becomes 0. So this is the first function. And based on that, if you have a function given as y is equal to 5, dy dx will be equal to 0. So this is a function. Whatever it is, if you have a function that is just a constant standing on its own, the derivative of a constant will be 0. That's the first rule of derivatives. Now the second rule of derivative is what we call the linear function rule. The linear function rule. The linear function rule says that if you have a derivative that has a constant with a variable that has a constant with a coefficient x, without any power, the derivative of this function, dy dx, will be left with k. The derivative of this function, that is finding the derivative of x in this equation, will be left with what? K. So that where you have a function such as y is equal to 2x, dy dx will be left with 2. In the next rule I'm going to show you, we are going to explain why we have 2 here very quickly. Next rule, even if you have y is equal to 5x, dy dx will be what? Will be 5. So this is the second rule of derivative. The third rule we're going to look at is what we call number 3, will be the power rule. The power rule says that where you have a derivative, where you have a function such as y is equal to kx raised to power n, where you have a function such as y is equal to kx raised to power n, dy dx will be n times k, then you have x raised to power n minus 1. So dy dx will be n. We're going to have n coming down to multiply k, then you have x n raised to power 1. So example of that will be where you have y is equal to, let's say, 2x raised to power 2. 2x raised to power 2. So dy dx of this will be 2 times 2. As you see, this n coming here times 2, which is, we have this one, raised to power 2 minus 1. And when you have that, your answer will be 2 times 2 is 4. Okay, 2x, I beg your pardon, there will be x here. So 2, this will be 2 minus 1. So this will become 4x raised to power 1. So it leaves you with 4x. Another example is to have y. Another example is to have y is equal to 5x raised to power 4. Now, to find the derivative of this function, that's dy dx of this function, will be 4 times 5, then you have x, and then you're going to have 4 minus 1. You see how the rule is playing out? So you have 4 times 5, you have x, 4 minus 1. So that your answer will be 20 x raised to power 3. So this is the power rule when it comes to finding derivative. You can have several other examples. Let me give another example of this. Another example will be y is equal to 1 over 3x raised to power 3. So the answer will be dy dx will be 3 times 1 over 3. Then you have x 3 minus 1. This becomes, if we cross out this, you are left with 1. So you have now x raised to power 3 minus 1 will be 2. So this is the answer for this function. So this is example of the power rule. Another example I may give you on the power rule, let's come to this side of our board. Another example I will give you on this power rule will be y is equal to 2x raised to power minus 5. These are several versions of power rule, so that our answer dy dx will be minus 5 times 2. You have x minus 5 minus 1. So when you have this becomes minus 5 times 2 will give us minus 10. Then you bring down your x here. Now minus 5 minus 1 will give us minus 6. So this is one example again of our power rule. Now let me give you another one again. We have y is equal to, let's say y is equal to, let's say y is equal to square root of 7x. Let's say y is equal to square root of 7x. So we can rewrite this. Let's rewrite as y is equal to 7x raised to 1 all over 2. We can write this as 7x raised to 1 over 2, which is according to the laws of indices. So now this becomes, if we want to differentiate this, dy dx will be, you know what we do? We map this, multiply by this, so this becomes 1 over 2 times 7. You have x, then this is 1 over 2 minus 1. 1 over 2 minus 1. So that our answer becomes 7 all over 2. You know, this multiplies. You have x raised to power, this is 1 over 2 minus 1, that's half minus 1, will give us minus 1 all over 2. So that we have an interesting case that our answer, we can rewrite our answer as 7 all over 2 x all over, okay, this reverses to x raised to power half. So this is the answer that we have here, as we have 2x raised to power half, because according to laws of indices, since we have a negative here, it will reverse to become a fraction. We have 1 all over half, so you have 2x, you have x. So this is our answer. So today this is the first part of our looking at the rules for determining derivatives. In this lecture, we have considered the constant rule. As you can see on the board, please let's look at what we have on our workboard. We've looked at the constant rule, where you have a function that's just having k. That's the constant rule. Then we have also looked at the linear function rule. This is a linear function rule. You have it there. If you have 5x, which will result in 5, then we have also looked at the power rule. The power rule can be presented in different ways. The power rule can be presented in different ways. So whatever example you are given, look at these examples and work out what to take you to determine this. In the next video, we are going to look at some other rules of differentiation. Thank you.